Dear students, in the last class I have explained a trigonometric function. The first one is a sine of an angle. So, sine of an angle is defined as the ratio of, it is the opposite side by the hypotenuse. Cos of an angle is defined as the ratio of adjacent side by the hypotenuse, whereas tan of an angle is defined as the ratio of the opposite by the adjacent. And we are going to use this ratio in our next topic. Whenever we add two scalars, let us take mass of 1 kg, mass of 2 kg. What is the total? Add them, 2 plus 1, 3 kg. Now, this is called algebraic addition because it is a scalar quantity. If I take a force 2 Newton, another force 3 Newton, what is the net force? Need not be 5 Newton, need not be 5 Newton. It may be equal to 5 Newton, but it is not always 5 Newton. Why? Because force is a vector. It has a magnitude and a direction. One more force, it has a magnitude and direction, and you can see there is some angle between them. So, the resultant depends on the magnitude of the two forces as well as the angle between them. So, that is why we have to find a relation between the individual vectors and even the angle between them. And that is what we are going to learn today. It is in the form of a derivation, and the question has appeared 4 times in the examination. And look at the question. The question is expression for magnitude and direction of the resultant of two vectors acting at a point. Expression for magnitude and direction of the resultant. So, we have to find the magnitude, we have to find the direction as well of two vectors acting at a point. Okay. So, let us take a diagram straight away. I am going to explain in detail. So, first O is the point here, okay, at which one vector is acting, and the vector is a P. It acts along OA, this is the direction, okay. So, magnitude is from O till A. There is one more vector, okay, whose magnitude is a Q, acts along OB. So, how many vectors are there? Only 2 vectors. What is the angle between them? The angle between them is a theta. So, theta is the angle between them. The theta can be 0 degree, 2 degree, 10 degree, 5 degree, 30, 30.5 degree, any angle. Theta can have any value between them, okay. It can be acute angle as well as the obtuse angle. Acute angle means lesser than 90 degree, obtuse means more than 90 degree, okay. So, that is the theta. So, what is the P? Magnitude of one of the vector. What is Q? Magnitude of the other vector. What is the theta? Angle between them. And I want to find the relation between P, Q and the theta. So, when we add two vectors, we get a third vector, that is called resultant. To find the resultant, we have a law, correct? What is that law? The law of a triangle of vector addition and the law of parallelogram law of vector addition, correct? Triangle of vector addition, parallelogram law of vector addition. So, that is why I am going to construct a parallelogram with the help of these two vectors. So, this represents one of the side, this represents the other side, and now construct a parallelogram. So, the parallelogram is here. So, therefore, the parallelogram is O, B, C and A, because in parallelogram the sides are parallel to each other, okay. So, what is the parallelogram? O, B, C and A. And where do we get the resultant? The resultant is always given by the diagonal of the parallelogram. See, the diagonal is here. So, this is the resultant. So, our aim is to find the relation between R, which is the resultant, P, which is one of the vector, Q, another vector, and a theta. So, what is the expression that relates R, P, Q and theta? That is what I am going to explain. Now, you can see you have to draw dotted line only, like this. See, these are all dotted line because these are real quantities. Okay, they are the imaginary, they don't really exist there. Clear? That's why 2 continuous lines, the rest are all dotted lines. Now what you do is you just extend this line beyond till D and draw a perpendicular here. Okay, so that this becomes a right angle triangle. Which one? C, A and D. So till O to A is the vector, beyond that just extension, that is to derive this particular expression. Okay, right. Now check this here, OB and AC are parallel. So that's why if this angle is theta, even this angle is also theta here, correct? What do we call such angles? Corresponding angles. Okay, this and this angle are corresponding angles, right? Okay, if this is Q, if OB is a Q, even AC is also Q, right? So I will write here OB and AC, they are equal, correct? OB and AC, they are parallel, right? So that's why it's equal to Q. Then OA, what is OA here? OA is nothing but P, right? So this is a Q. Now one of the equation which I am going to write from that is, see, this is a right angle triangle, correct? This is a right angle triangle. So if this is the angle, this is the opposite side, this is the adjacent side, opposite to the angle is the opposite side, the side perpendicular to the opposite side is adjacent, remaining is hypotenuse. So let us define now. Okay, that is CD by AC. Okay, CD by AC. What is a CD by AC? CD by AC. CD by AC is nothing but opposite by hypotenuse, which is nothing but sine theta, correct? No? So that's why CD is equal to AC sine theta. So CD is equal to AC sine theta. Okay. Next, AD by AC. AD by AC is nothing but cos theta, right? Adjacent by hypotenuse is cos theta. Therefore, what is the AD is equal to? AD is equal to AC cos theta. AD is equal to AC cos theta. AD is equal to AC cos theta. Okay. Now, why I am writing all these sides? Because we are going to use this data later to complete the derivation. Okay. Next, this is a right angle triangle. I can relate all the 3 sides with the help of the Pythagoras theorem, that is CD square plus AD square, correct? No, is equal to AC square. So therefore AC square is equal to AD square plus CD square, correct? Correct? No, AD square, correct? AD square plus CD square is equal to AC square. That is using the Pythagoras theorem. Okay. So now we are ready with all the data here. Now let us continue as how we can complete the derivation. So one more point which I didn't mention here is about an angle here. This angle is represented by a Greek alphabet symbol. It's a alpha, okay? Alpha symbol. So what is alpha? Alpha is the angle between the resultant and vector P, okay? R is the angle between the resultant and the vector P. R is the angle between the resultant and vector P, whereas the theta is the angle between P and Q. Fine? Okay. So now how to complete this particular derivation? So for that I am going to start with this triangle. Look at the triangle, it's all about the complete mathematics. The triangle is OCD, triangle O, C and D. So keep looking at the diagram. I will write here triangle OCD. Use Pythagoras theorem for that, okay? OC square is equal to OD square plus CD square, okay? Is it correct? OC square, which is this, OC square is equal to OD square plus CD square, correct? No? Because it's a right angle triangle. I can use Pythagoras theorem, okay? The next step, OC square is equal. That OD is there, you can split into 2 parts, you know. it's OA plus AD, okay. OD is nothing but OA plus AD, the whole square, correct. OD I have split it into two parts. One is OA plus AD, the whole square, plus this one CD square, okay. All right. Now that is equal to, now let us apply this, a plus b the whole square formula for it, okay, for this. What is a plus b the whole square? First one, a square plus 2a and into b plus b square. It's on the same, right? A plus b the whole square is equal to a square plus b square plus 2ab, correct? Same thing, right? Plus cd square. Okay. So that is OC square. Now I am going to write again the same step. OC square is equal to OA square plus 2 into OA into. From this, what is the AD? See, it's already ready. What is AD? AD is nothing but AC cos theta. So replace AD as AC cos theta plus, combine this, AD square plus CD square. Here it is, see, AD square plus CD square is nothing but AC square. AC square, right. So that's it, we are done with the formula here. Now it's time to substitute, okay. What is the OC? Look at the diagram. OC is nothing but R, correct? So it's R square. So R square is equal to, what is OA in the diagram? OA is nothing but P. So that's a P square plus 2. OA is nothing but P into, what is AC? AC is this. AC is nothing but Q, because these are parallel, right? Into Q. This is cos theta plus AC is nothing but Q square, okay. So one more step, R square is equal to P square plus, I will write this first, Q square plus 2PQ cos theta, or we write R is equal to root of P square plus Q square plus 2PQ cos theta. So this is the formula for the magnitude of the resultant. So I have told you, right, the relation between R, P, Q and theta. This is the one. So what is that? Remember, very important, we will be using this here as well as the second year syllabus also we use this equation, okay. So what is the formula? R is equal to square root of P square plus Q square plus 2PQ cos theta, where what is R? The resultant. What is the P and Q? Individual vectors. What is the theta? Angle between these two vectors. So therefore, when you add two vectors, you have to use this particular formula. You cannot directly add them. Why? Because it depends on the angle between them. Clear? Right. Now we have found the magnitude. So now we know magnitude is here. What is the direction of it? Where do we get the resultant? To find the direction, we measure this angle alpha. So for that, I am going to consider tan alpha from the triangle. I will write here, from the triangle OCD, from the triangle OCD only, I will define tan alpha. You can see in this derivation, we have used all the three functions, sine, cos as well as the tan. So I will measure tan alpha. How to define tan? Tan is nothing but the ratio of, see in this triangle, this is a triangle, okay, the ratio of adjacent, the ratio adjacent here by, sorry, opposite by the adjacent, correct, which is a CD by OD, okay. It is the ratio of CD by OD. It is the ratio of opposite by adjacent, clear? Opposite is this and this is the adjacent, okay. So tan alpha is equal to, CD is nothing but here AC sin theta, AC sin theta divided by OD can be split into two parts, OA plus AD, OA plus AD. So tan alpha is equal to AC sin theta divided by OA plus AD is nothing but AC cos theta. AC cos theta. Now time to substitute. Tan alpha is equal to AC. AC is nothing but Q. So Q sin theta divided by OA is nothing but P here. P plus Q cos theta. So using this you can find the direction of the resultant. Where do we get the resultant? Whether the resultant will be closer to P or whether it's closer to Q, where exactly that R is located. To find that, we have to find the angle alpha. So which are the two formula? One is magnitude of the resultant is given by R is equal to root of P square plus Q square plus 2PQ cos theta, and the direction of the resultant is given by tan alpha is equal to Q sin theta by P plus Q cos theta. You can even write like this. You can retain only alpha and then take tan to the other side. When you take tan to the other side, it becomes a tan inverse. Okay, right? Tan to the power minus 1 into Q sin theta by P plus Q cos theta. You can even write like this also. Okay. Either you can write tan alpha formula or you can just retain alpha, and when you take tan to the other side, it becomes tan inverse. This is how we read. Okay. Tan inverse is equal to Q sin theta by P plus Q cos theta. Hope you have understood this derivation. So very important. Only by writing you can learn physics. Okay. Not just reading, not just mugging up. So you need practice. So be regular to your preparation, not when you get to time. So you have to sit on regular basis and then you have to prepare for topic becomes more and more difficult. So if you don't prepare, you cannot perform in the examination. Clear? Okay. So final, again the resultant formula which I have derived, R is equal to root of P square plus Q square plus 2PQ cos theta, and tan alpha is equal to Q sin theta by P plus Q cos theta. Or you can even write alpha is equal to, take this tan to the other side, and when you take tan, it becomes tan inverse of Q sin theta by P plus Q cos theta. Okay. Right. So now I'm going to consider a few special cases. Okay. Now what are these special cases? They are all important from the exam point of view. Now what do you mean by special cases? Special cases are this. When theta is equal to 0 degree. See, I had given the diagram like this. This is P, this is Q, correct? This is theta. If theta is 0, what happens? So this is the case 1. If theta is equal to 0 degree, then this vector Q will come along P, correct? No? Like this. Then vector P and vector Q, they will act along the same direction. Then what is the value of R? R becomes a P plus Q. How? So let's see. R is equal to root of P square plus Q square plus 2PQ cos theta. In the last class I had given one standard table where we have a cos 0 value, because now theta is 0, right? What is cos 0? The value of cos 0 is 1. So we get root of P square plus Q square plus 2PQ, because cos 0 is 1. What is this P square plus Q square plus 2PQ? This is of the format A plus B the whole square, correct? A square plus B square plus 2AB. So what is the square root of P plus Q, the whole square? It becomes only P plus Q, because square root means to the power half, right? That's to the power half square. And again there is a square. Again there is a square. So this will get cancelled. So that's how you get P plus Q. So that is the reason why when theta is 0, directly you can write the resultant. Resultant is always P plus Q. That is only when theta is equal to 0, not for all the angles. Okay. What is the direction of the resultant? The direction of the resultant will be along this direction only. So R is along the direction of the given vector. It's a very easy to understand. I am going to consider a block. I will apply force like this. I will apply one more force, and both the forces are in the same direction, therefore the body will move like this, indicating that the resultant also acts in that particular direction. So that is case number 1. I hope we all have understood. And when theta is 0, we are going to get the maximum resultant. So maximum resultant is possible when vectors are along the same direction. So what do you mean by theta 0? Theta 0 means both the vectors act along the same direction. Then the resultant we get, what we get is a maximum. Yeah. So let's take when theta is 90 degree. What do you mean by theta 90 degree? Theta 90 degree means one vector is along this direction, the other will be along some other direction, making an angle of 90 degree. See, perpendicular, we call it as a perpendicular vectors. So now what is the general formula? R is equal to root of p square plus q square plus 2pq cos theta. What is the theta now? Theta is 90 degree. Theta is 90 degree. What is cos 90 degree? That's equal to 0. Again, look at the table. So that's why study the table, the one with the standard values which are given. Okay, like sin 0 0, sin 30 half, sin 45 1 by root 2, sin 60 root 3 by 2, and sin 91. Cos 0 1, cos 30 is root 3 by 2, cos 45 1 by root 2, cos 60 is half, and cos 90 is 0. Then tan 0 0, tan 30 is 1 by root 3, tan 45 is 1, tan 60 degree is root 3, and tan 90 infinity. So you should know this entire table by heart. Okay, so that's how we use this, cos 90 0. Now when this is 0 and see cos 90 becomes 0, this term becomes 0. So what is left? Only r is equal to root of p square plus q square, square root of p square plus q square. So that's how we get the resultant when theta is 90 degree. Now here, where do we get the resultant? The resultant, one vector will be like this, other vector will be like this, and the resultant will act in between the two like this. This is the resultant, making an angle alpha. And I can find that angle alpha. How to find alpha? Use a general formula, right? Tan alpha is equal to q sin theta by p plus q cos theta. Tan alpha is equal to q sin 90, sin 90 is 1 by p plus q cos 90 is 0, so this term becomes 0. So what do you get? You will get tan alpha is equal to q by p. So that is how you can find the direction. So here the direction of the resultant will be along the given vector, but here the direction can be found using a formula called tan alpha is equal to q by p, and that alpha will be here. Okay, this is that angle, and the resultant will act in between the two vectors. Okay, making what angle? Given by this formula. So this formula is used only when theta is 90 degree, or only when the vectors are perpendicular to each other. So when theta is 0, resultant is a maximum p plus q. What is the direction of the resultant? Along the given vector. When theta is 90 degree, what is the resultant? R is equal to root of p square plus q square. What is the direction of the resultant? Given by a formula called tan alpha is equal to q by p. The last case, when theta is equal to 180 degree, that is like this. One vector is here, the other vector has to be opposite, only then they make an angle of how much? 180 degree. Okay. So here I am going to give you one value which is, you have to remember, cos 180 degree is equal to minus 1. So keep this in mind. You will learn this in mathematics as how cos 180 is minus 1, but do remember cos 180 is minus 1. Now what is the formula for resultant? R is equal to general formula root of p square plus q square plus 2pq cos theta. What is cos 180? Minus 1. So what do you get? R is equal to root of p square plus q square minus 2pq. That is what you are going to get. Minus because of this. Now what is this equal to? This is of the format a square plus b square minus 2ab, which is p minus q the whole square with the square root. How much is that? It's a p minus q, with the assumption that p is greater than q. So we get minimum resultant, R minimum. Okay. So when theta is 0 degree, resultant is maximum p plus q. And when theta is 180 degree, the resultant is minimum, which is p minus q, if p is greater than q. If p is greater than q, the resultant will be along this direction, along the greater vector. R is always along greater vector. If q is greater, then the resultant will be like this. Okay, it's very easy to understand. you take example of a block. A person is pulling the block here in this direction with a force of 10 Newton. Another man pulling the block in this direction with a force of 2 Newton. Now in which direction the block moves? Obviously it will move in this direction. Why? Because this is greater. Can the block move in this direction? Not possible. So that is what we can understand. R is always along greater vector. Now what if both of them, if they pull each other with same force? What happens? Will the block move? No. The block will remain at rest. So that also we can understand. Check this. One is 2 Newton, other is 2 Newton. Substitute now here. 2 Newton minus 2 Newton. How much? It's a 0. So no resultant. The block will not move. So hope you have understood the three cases. So let me again very quickly revise. The general formula for the resultant is R is equal to root of P square plus Q square plus 2 PQ cos theta. Tan alpha is equal to Q sin theta by P plus Q cos theta. Only repetition will help you to remember things. Repeat again and again and again. Write in a sheet of paper formula again and again. Okay, 10 times, 15 times. This is the way to learn. Not just looking at the video and then trying to remember things are not possible to study. This is not the way to study. Take a book and write this derivation. Study. The notes is there. Entire derivation. See the steps. And if you have any doubts, so definitely you can clarify your doubts at any point of time. Okay. So these are the three cases. Again, let me quickly revise the three cases. Theta 0, R is maximum, P plus Q. The direction of the resultant along the given vector. When theta is 90 degree, R is equal to root of P square plus Q square. Direction is given by tan alpha is equal to Q by P. And when theta is 180 degree, which means when the vectors are opposite to each other, the resultant is minimum given by P minus Q. If P is greater. Now what if Q is greater? Then R is equal to Q minus P. Okay. What about the direction of the resultant? Always along greater vector. If P is greater, resultant will be along that direction. If Q is greater, it will be along the Q. Are you following, students? Okay. So these are called as the special cases, of the vector addition. So directly we can use them whenever we are in need of these equations. Okay. As I've told you, this is important. Why it is important even in the next year? Because vector is a quantity that we come across in a lot of chapters, not just in this particular chapter. That's why it is important. Fine. Okay, so let's see some questions. Okay, based on this. When will be the resultant of two given vectors is maximum? So when the resultant is maximum? The resultant is maximum when angle between the two vectors is 0 degree or when two vectors act along the same direction. So that is the answer to that particular question. What is the minimum number of vectors to give 0 resultant? We get 0 resultant when there are minimum two vectors are there which are equal and opposite. Okay, P and Q are equal, making an angle of 180 degree. We get resultant P minus Q, and since they are equal, we get 0 resultant. So what is the minimum number of vectors to give 0 resultant? The answer to this question is we need minimum two vectors. With single vector, we can't get a 0 resultant. Correct? What in by resultant? Resultant is nothing but the vector that we get after adding vectors. And to add vectors, how many minimum vectors that we need? We need two vectors, right? We can add more vectors also, not just two. We can add 3, 4, 5, any number of vectors. But question is minimum. How much is required? Minimum. We need 2. So that is the answer. When is the vector addition of two vectors maximum and the minimum? Okay, so maximum, it's already answered here. So vector addition of two vectors is a maximum when two vectors are along the same direction or when the angle between the two vectors is 0 degree, and it is a minimum when the vectors are opposite to each other or when the angle between them is 180 degree. Okay. So hope you have understood the important equations, and again we are going to use them in one or the other topic. So that's why practice this derivation, very important. I am going to continue the rest or more about the vectors in the next class. Thank you.